remember, if you have just a polynomial, right? If you just have a polynomial, so like for B and for D, you just have to look at the leading term. All right, so you just have to be careful. Like 4 is not the leading term for B. All right, it's negative x cubed. It's if the highest exponent, that's the leading term. They're not always going to be in the right order. And you just have to substitute into that one term. This means nothing. So when infinity cubed is still going to be positive, but that negative out front makes that negative infinity. All right. For D, 8, this one here is the leading term. You don't care about any of this. You just plug positive infinity in there and you would get positive infinity. All right. So that's how you deal with polynomials. Fractions is where you have to worry about those three cases. You look at the degree. Is the degree larger on top? Is it larger on the bottom? Or is it the same? When it's larger on the bottom, like we have in C, right? If there is no x up top, that means its degree is 0, all right? In C, it's 3 on the bottom, so obviously this is bigger. We love when that happens because the answer is always just 0. Right? If, like in A, you have a case where here's our on the top, this is on the bottom, they are the same, both 3. You take the leading coefficients and just simplify them. That's a 1, that's a 3. The answer is just 1/3. All right, that's all you have to do. The case that we like the least is if it's larger on top, and that's like F. We have 2x to the 4th, and we got 5x. So the degree at the top is 4, the degree in the bottom is 1. So this is not a horizontal asymptote, this would be a slant, but for the purpose of finding a limit, it's either positive infinity or negative infinity. To figure out which one it is, you just simplify the leading terms, 2x to the 4th over 5x. That would simplify to 2x cubed over 5. And then you substitute in your positive or negative infinity. In this case, it's negative infinity. Cubed is going to stay negative, times a positive is still negative, divided by a positive is still negative. So that is negative infinity, right? You have 50-50 shot with ones like that. If you're not sure, you can always just guess. All right, so those were examples of 3 different cases. All right. Let's see what else I want to show you. Okay. Now, ones with the trig. I know I didn't talk about this yesterday, but these are actually very easy. So like J and O. If you think about what the graph of sine looks like, the graph of sine constantly does this, right? It just keeps going up forever. So remember what a limit is asking for. It's asking what's the y value that it's approaching. Well, it goes up and then it goes to this one, then it goes up and then this one. It keeps going constantly to one up top and one below. It's never going to approach anything. So when we don't have a limit, we say D and E does not exist. So anytime you have a limit of a sine one that's going to positive or negative infinity, it does not exist. Cosine is the same thing. The only difference is it starts up top, but same thing happens. It's D and E. So if you see a limit with a sine or a cosine, it's always D and E. As long as the limit is going to infinity, which we are doing right now, or negative infinity. The only other one I want to make sure I talked about was L. The square root, the radical here was up top. That's okay. And just because 5 is not a perfect square, who cares? All right. If you remember, we take the leading terms and you take the square root of 5x squared. Well, the square root of 5 is just the square root of 5. You can't do anything with it, so you just leave it like that. X squared is x. Now remember, it's plus or minus x. You determine that based off of what you're approaching. Since we're doing negative infinity, we use negative x. If it was positive infinity, we would use positive x. We simplify, and that answer is negative square root of 5 over 2. All right. Now, does anybody have any questions on any of the other ones that you wanted me to go over on the limits, I should say? I think that pretty much covered most of them. So then besides the limits, we were also talking about asymptotes. All right. Now, to find vertical asymptotes, we always just set the bottom equal to 0, and we label it x. So in this case, this would be x equals -4. This one here is x equals plus or minus 2. This is just x equals 5. This one if I set equal to 0, I get x squared equals -4. Take the square root. That's square root of a negative number. Can't have that. That's a plus or minus 2i. So in this case, there would be no vertical asymptotes. Where is that? Oh, it's right there. So there would be no vertical asymptotes. So that's vertical asymptotes at the bottom equal to 0. To do the horizontal or the slant, that's just like what we did above. You're looking at the degree. The degree in this one, larger on the bottom, automatically 0, y equals 0. There is no slant. Make sure you just put a slash there. Here, larger on the bottom, y equals 0. Just put a slash. Here, the degree is 1 on top, 1 on the bottom, which means there's no slant. We take the leading coefficient, which is 1 over 1, which is 1. All right, and then you just go through and do those. All right. All right. Any questions on anything from the assignment from last night? Okay. So what we're going to do today, if I could find it. All right, we're going to do this problem right here. All right, so we have this function, x cubed minus 3x squared. And we're going to fill in all of this information. Asymptotes, intercepts, symmetry, first derivative, second derivative, increasing, decreasing, max and mins, concavity, points of inflection. We're going to use all of that to be able to graph it. So all of this technically is one problem. All right, obviously a bunch of little parts, but they all have to do with x cubed minus 3x squared. Okay, so we're going to break this up into sections here. This is the first thing we're going to worry about. These 6 things: vertical, horizontal, slant, asymptotes, x-intercept, y-intercept, symmetry. All right, so this is a polynomial. The great thing about polynomials, first off, they're easy to find derivatives of, but also they have no asymptotes. So if this was an assessment, you get 3 easy points here. Slash, 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 1, 2, 3. 3 points. All right, there are no asymptotes. You can write none or just put a slash mark. Don't just leave them blank. All right, don't leave them blank. All right, now to find an x-intercept. All right, to find x-intercepts. X-intercepts are always in the form of some number, comma 0, right? It's where it hits the x-axis. The y-coordinate is 0. So what we're going to do is we're going to set it equal to 0. And what I'm going to say is I'm going to say set the top equal to 0. And you're going to be like, well, there is really no top and bottom here. You're right. But when there is a fraction, we do want it's the top that's equal to 0. It's not the bottom. In this case, actually, I could say there is a top because it's over 1. So we're setting x cubed minus 3x squared. We're setting that equal to 0. Remember, all of this stuff here, these things I have in a box, is all based off of the original. Nothing to do with the derivative yet. It's all based off the original. So if I set this equal to 0, what can I do? I can take out an x squared, and I'm left with x minus 3. So I'm left with 0 and 3. That's where it hits the x-axis. So I have 2 x-intercepts here. I have 0, 0, and 3, 0. Remember, it's always whatever you get, then comma 0. All right? That's how you find your x-intercepts. Right? I'm going to say set the top equals 0, but if it's a polynomial, you just set the whole thing equal to 0. For the y-intercept, y-intercepts are always in the form of 0, comma, whatever your y-intercept is. So to do this, we are going to plug in 0 for x into our problem and simplify. This problem, real easy. Plug in 0, I get 0. Plug in 0 there, I get 0. 0 minus 0 is 0. So my y-intercept is 0, 0. If you have an x-intercept that's 0, 0, your y-intercept will always be 0, 0 as well. You will only have one y-intercept if there is one. Doesn't have to be a y-intercept, but if there's only one, you can't have more than one. X-intercepts, there can be more than one if there's any at all. It is possible not to have an x-intercept. All right. Any questions on how to find x or y-intercept? I know you guys have done it before, but just a review. All right. Now, the last part of this section is symmetry. meaning is it even symmetry or odd symmetry? Now, I know you guys did this in pre-calc, I should say. Even symmetry is graphically where it's symmetric about the y-axis, meaning if you flip a graph over the y-axis, it looks exactly the same. Odd symmetry is when it's symmetric about the origin, meaning if you rotate it 180 degrees, it's exactly the same. But we're going to figure this out algebraically, all right? And this is the thing I'm least concerned with because everything else is more important in my opinion. This we can also check once we graph it. But algebraically, the way to check if something's even, odd, or neither is you are going to plug in negative x. You're going to do f of negative x. If f of negative x equals the original, then it is even. Then it has even symmetry. If you plug in f of negative x and it equals negative f of x, meaning like the opposite, then it is odd. If neither of those things happen, then the symmetry is neither. It doesn't have to be even or odd. And in fact, most of these problems we're going to do, if you had to guess and had no idea, I would guess neither. All right. So for this one, if I did f of negative x, I would get negative x cubed minus 3 times negative x. So I would get negative x cubed plus 3x. All right. So that's what I get when I plug it in. If it equals the original. So does that equal this? No, right? Because I have x cubed minus 3x right here. I have negative x cubed plus 3x. Wait, hold on a second. I did something wrong. No, I didn't. Oh, I didn't put the square. My bad. There you go. I know I did something wrong. Okay. So negative x squared, that's positive. So this stays a minus. There you go. So I get negative x squared minus 3x squared. This does not equal that. This negatives match up the second one, but the first one's positive, and that one's negative. So it is not even. In order for it to be odd, what would have to be true? Negative f of x would be negative x cubed plus 3x squared. Hey, Catherine, can you answer this? Sorry about that. All right. So in this case, we have negative, negative, but this one's positive, that one's negative. So this one is not odd either. And like I said, a lot of times it happens, it is neither. All right. And we'll be able to tell once we graph it that there is no symmetry about this whatsoever. All right. So all 6 of these things always have to do with the original. Polynomials are the best because it's easy. There is no asymptotes. You just have to worry about the intercepts and your symmetry. All right. Now, questions up to this point. All right. So now we get to the part where we've done a bunch of this in the past. And just to review real quick, I want you guys to then now do this part here. So I want you to find the first derivative, second derivative, do the critical values, figure out where it's increasing, decreasing, concave up, all this information here. And like I said, these are nice, easy derivatives. I'll even do the first derivative for you. Just set it equal to 0 and go from there. All right, so I'll give you a few minutes to try to figure each of those out. Kat, what does she want? Hey, what's up? Did you have a question or something, or? No, there's the questions are I just put myself in mute. Working on something right now. Yeah, no, we don't have any such thing as security anymore. Now you can turn on. Yeah, it sucks. I mean, it does, but then it's also that you don't have to go to school next week. So it's still pretty good here. Yeah. Where are you flying? Where are you flying into? Okay, how's the weather there? Gotcha. What time's your flight? safe flight. We just had our person come to like go through our final bill. We went over by less than 10%, so we're going to get some money back because our mortgage was at 10% contingency already built in to that. So we will be getting a couple grand back. Yeah, he said he's like that's actually great. He's like most people are like 20% over. Yeah, so yeah, I'll pay for some of the girls' sports that we do a lot of. So yep, but all right. Yeah. Well, we're sleeping over tomorrow, and then you're coming over, here on Sunday.
Yes.
Yeah, we're doing pierogies, remember?
Oh, right. Do we?
Yeah. All right. I got it. Yeah, bye.
It's snowing hard.
It is snowing hard right now, Moss. You were correct. All right, let's see here. 6, 7. All right, so first derivative is 3x squared minus 6x. Set that equal to 0. Take out a 3x. I get x minus 2. So my two critical values are going to be 0 and 2. All right, so we've done this many times. We now plug in. Remember, plugging into the first derivative. When I plug in a negative number, anything less than 0, that's a negative there, negative times a negative is a positive. I plug in 1, I would get a positive times a negative, which is a negative. Plug anything bigger, I would get a positive times a positive, which is a positive. So this is increasing from negative infinity to 0, union 2 to infinity, and it's decreasing from 0 to 2. All right, max and mins happen wherever they change signs in the number line. It changes at 0 and 2. You just have to figure out increasing and decreasing means a max. So that's 0. And the min happens here when it goes from decreasing to increasing. Remember, you plug back into the original to get your y. So when I plug 0 into here, 0 minus 0 is 0. When I plug in 2, 2 cubed is 8. 2 squared is 4. 4 times 3 is 12. 8 minus 12, what is that? Negative 4. Thanks. You guys didn't really care what I was saying anyway, so that's fine. All right. Hopefully, like I said, it was nice speaking to myself for a little bit. I'm used to that. If you guys have any questions how I found this, hopefully you guys know we've done so many of these. Just let me know and I'll repeat it. Otherwise, here, second derivative 6x minus 6. Then this is what? What is that? 1. Plug in anything less than 1, that is a negative. Anything greater than 1 is a positive. So it is concave up from 1 to infinity, concave down from negative infinity to 0. We have a point of inflection where it changes, and that's at 1. Plug it in, I get negative 2. All right. Now I know I went through that, kind of fast, but that's because we've spent so much time doing that over the course of the time that, hopefully, especially with a polynomial, you guys are good. All right, so now this is where, we get to some new stuff here. We are now going to do is we're going to take all this information, and as it says here, take all the information you found from the above number lines and organize into the following number line. All right, so we have a big number line here. What I'm going to do is I'm going to put any critical values from the two number lines I've already done. So any number that's been written on there, as long as it's been on there once, I don't care if it's been on there twice, at least as long as it's been on there once, it gets put down on this big number line. So we have 0, 2, and 1. So obviously make sure you put them in order. 0, 1, and 2. All right, so I now have 4 intervals here. Less than 0, between 0 and 1, between 1 and 2, and greater than 2. Now, what I'm going to do on the top part of this number line is I'm going to rewrite where it should be increasing and where it should be decreasing. And all this information I already done, I'm just consolidating it to one number line to make it easy for us to get information from. So everything that is less than 0 is increasing, but also where it is greater than 2. So less than 0 is increasing, greater than 2 is increasing. It was decreasing between 0 and 2. So it's decreasing between 0 and 1, and it's decreasing between 1 and 2. Now I'm going to do the same thing for concavity, but I'm just going to put that on the bottom of the number line. So it was concave up bigger than 1, so between 1 and 2, and then 2 to infinity. And then it was concave down less than 1. All right, now you're like, well, why am I doing this? The reason we are doing this is because I now know what the curve, the function is going to look like. The shape is going to look like. I know that when it's less than 0 here, it's going to be a curve that's increasing and down. Well, increasing and down looks like this, right? That's an increasing function, but it's also concave down. Decreasing and down looks like that. All right, if you put them together, they're the two parts of a parabola, right? This is the increasing part. This is the decreasing part, all right? Increasing and down, decreasing and down. Now, this part is decreasing and up. All right, decreasing and up looks like that. Increasing and up looks like that. If you put those together, right, those are the two parts that are probably going up. That's decreasing and up, that's increasing and up. So you really need to know when it says, oh, it's decreasing and down, what that curve looks like, all right? You need to know what that curve looks like. And this is a good example. The reason we start with this is because it gives us all 4 of them all in one. You're not always going to have that. All right, not always going to have it. Sometimes you could have something that's all increasing. There are functions like that, or all decreasing, or always concave up, or vice versa. All right, now once we have our number line, we now get to actually graph. All right, now first thing we do once we get to this graph part, and this, whether we're doing a polynomial or we're doing a fraction problem, it doesn't make a difference. The first thing we want to do is we want to plot our asymptotes, if there are any. In this case, we have none. We want to do our x and y intercepts. We want to put any max or min points, and we want to put points of inflection. So all of that information from above, that's what we want to graph first. So obviously we don't have any asymptotes. If we did have asymptotes, when we have fractions, we would put them in there. X and Y intercepts. So we had 0, 0. And if I remember correctly, it was 3, 0. So we got 0, 0, and 3, 0. Let's see. Let me just scroll down just a little bit. Okay, max and mins. My relative max was 0, 0. Well, I've already graphed it. Oh, and the Y-intercept was also 0, 0. So it's already there. Relative max, 0, 0. It's already there. Relative min, 2, -4. So 2, -4. I'm just going to put it like right here, label that -4. You will have some points sometimes that are like -32. Well, you're not going to put 31 slash marks, right? Just put it so it's, down below somewhere, and that whatever, if you have several points down here, that it's in some sort of order. All right. And then the other point, which you can see up here, which was what, 1, -2, that was a point of inflection. So put 1 and a -2, label that. And we have that right there. So we have 0, 0, which was an x-intercept, a y-intercept, and a relative max. We have 1, -2, which is a point of inflection. We have 2, -4, which is a relative min, and we got 3, 0, which was an x-intercept. So we've plotted all of those points. All right. So once we plot, the second thing we do is we do our curves. All right. So now we just use the number line. All right. And all of this we can get right in the number line of what should be happening. So, and basically what we're doing is you're playing dot to dot, all right? Connect the dots. We're going to connect those dots with curves that look like this. Obviously, the ones on the end will have arrows on them. So increasing and down. So from here, that is an increasing and down curve. Then between 0 and 1, I need to do something that's decreasing and down. So it comes right here. And then once between 1 and 2, it's decreasing and up. Then 2 to infinity, it's increasing it up, but I have to make sure I go through my x-intercept. I have to make sure I go through my x-intercept. So it looks like that. All right. So let's just take a look at this, right? This good looking graph. There's a polynomial. All right. And the nice thing is, and you might remember you've graphed polynomials like back in algebra 2, and maybe you did in pre-cal where you found the zeros and then you figured out if things were bouncing or whatever. Well, normally, now we're more specific. We now know a little bit of a change of inflection now because of the derivative. Before, you might have just draw one curve connecting those two. But look at our points. This point right here, 0, 0. Obviously, it's an x-intercept and a y-intercept, but that was a relative max. Look at the graph. It is a relative max. This point here, 1, -2, that was a point of inflection. Notice it goes from, changes concavity here. It goes from concave down to concave up. This point here, 2, -4, was a relative min, and you can see that as a relative min. Right? So we were able, all right, to graph this function all based off of the information we found from the derivative and all the other stuff, not really knowing anything about how to graph an x cubed graph. All right, this is all based off of the stuff we learned from the derivative. All right, questions? Okay. All right, let's see, is this the one? Yeah, all right. So what I have assigned to you, what I want you guys to do right now and then for tomorrow, basically, all right, is I said in the assignment to do section 2, number 1, just so you know which one it is. I'm talking about this guy right here, x to the 5th minus 5x to the 4th. And you can see it as, find the x and y intercepts, find the asymptotes, say whether it's even or odd, then increasing, decreasing, all that stuff. Then you have concavity, points of inflection, you have the big number line, and then you have the graph, right? So this is done very, very similarly to the one that we just did, all right? So if you could do that for tomorrow, I would appreciate it. And then we'll go over that one. And then tomorrow, I will show you, we will do one that is a fraction, all right? And fraction's a little bit more involved only because it has, it's got asymptotes and all that stuff involved in it. But it's going to be the same basic thing. And then we'll spend a couple days practicing this before we eventually take some sort of assessment. All right, questions? All right, well, get that done for tomorrow. If you guys venture out today, stay safe. Otherwise, I will talk to you guys tomorrow.
Thank you.
Thanks, guys.